52 summation at n goes from 1 to infinity, 2 to the n minus 3 to the n, all over 5 to the n. Hopefully this one's pretty easy. We can actually directly find the sum. So let me actually go over that first. We can rewrite the series as, we can bring up the fraction 2 to the 5, 2 over 5 to the n, 3 over 5 to the n. And then you, so break up the fraction and then use properties of exponents, okay? So how do we find the sum of an infinite geometric series? These are geometric series, right? Some common ratio to the n power. So the common ratio has to be less than 1 in order for it to converge, which they both are. So it is the first term divided by 1 minus the common ratio. First term is, well, it's starting from 1, so n equals 1. That's 2/5 over 1 minus the common ratio, which is 2/5 as well. Similar over here, 3/5, 1 minus 3/5. Okay? And then if you do the math, it's minus 5, 6 is clearly finite, so it's a convergent series. Alternatively, you could also just since this question is only asking for the convergence of it, you don't actually need to find the sum like I did down there. I just did it because some commenters in the past thought it was easier to just find the sum, which you could do, but I think honestly, it's actually more work than just justifying that these are both geometric series with the common ratio less than 1, so it converges. That's all the question asked. You just have to prove the convergence or divergence. The question didn't ask for find the sum actually. So if it asks you to find the sum, then yes, you need to do this. Otherwise, you don't need to do it and just say that the common ratio is less than 1, therefore it converges.